Okay, boys and girls, ladies and gentlemen, today we are solving two-step equations. Think about this present. Whoever wrapped this present had to start by putting the present in the box, and then wrapping the box, and then putting the bow on the box. Now, whoever gets the present, it has to go exactly in the opposite order to get the present out of the box. They're going to start by ripping the bow off, and then ripping the paper off, and then opening the box and taking the present out of the box. So they have to go in the exact opposite order of whoever wrapped the present. In class, we're going to talk about a lot of different ways to solve a two-step or multi-step equation. But for right now, I want you to think of solving any multi-step equation, any equation that involves more than one step to solve, as unwrapping a present. You're going to go exactly in the opposite of the order of operations as you would to simplify.
Giaffino, please report to the front.
When we're simplifying, we say we start with the parentheses, then we simplify any exponents. We're going to do the multiplication left to right, and then our addition and subtraction. We're going to go exactly in the opposite of the order of operations. So we're going to see if we can add or subtract away from the variable. Then if we can multiply or divide away from the variable. Simplify any exponents, which we won't have at all this year, and then simplify the parentheses. So we want to go exactly in the opposite the order of operations as we would if we were simplifying. So we want to start with adding or subtracting away from the variable. First, you need to identify where the variable is in your equation. In this case, my variable is a, and it's right here. So I'm going to look at the left side of the equation because the left side of the equation is, in this case, the side of the equation that has the variable. So I want to see if I can add or subtract away from the a. What is being added or subtracted to the term that has the a? Oops, excuse me. Well, this 13 is being added to the negative 2a. The negative 2a is the term that has the a. So I want to add or subtract away that positive 13. So I can say I'm subtracting positive 13 or adding negative 13 either way. It's often a good idea to put that dashed line coming down from the parentheses to remind yourself that anything you're going to do to one side of the equation, you need to do to the other side of the equation. So I'm going to make sure I'm showing my algebraic step that I'm adding negative 13 to both sides of the equation. My positive 13 and negative 13 add together to equal 0 there. So I'm just left with my negative 2a. I'm going to bring down the equal sign. Now on the right side of my equation, the positive 27 and the negative 13 combine to equal positive 14. So now I have negative 2a equals 14. I've done my first step of adding or subtracting away from my variable, and now I can see if I can multiply or divide away from my variable. I notice that my negative 2 is being multiplied by the a. So I can show that I'm going to divide both sides of my equation by negative 2. If you want to, you could also show that you're using your multiplicative inverse and multiplying both sides by negative 1/2. Remember, those mean the same thing. I'm going to show that I'm dividing by negative 2, but either way is fine. Again, bringing down my equal sign. On the left side of the equation, the negative 2 divided by negative 2 is positive 1. So I'm left with just 1a, or you can just write a. On the right side of the equation, positive 14 divided by negative 2 gets me negative 7. So my answer is a equals negative 7. It is always a good idea to check, especially as you get into harder and harder algebra. To check, all you need to do is substitute the answer for your variable back in for your variable into the original problem. Go ahead and simplify the left side of my equation, and my goal is to end with something that's just true. So negative 2 times negative 7 is positive 14, and I'm left with 27 equals 27. That is true. 27 does equal 27, so I know my answer is correct. A equals negative 7. Here's our next problem. Now, for this one, looking at the left side of my equation, I noticed that that side of the equation isn't in simplest form. Generally speaking, and not always, but almost always, if you can simplify either side of your equation, you're going to want to start by simplifying. So in this case, the 3x and the 5x combine. They're like terms. I can combine those to make 8x. Generally speaking, if you can simplify either side of your equation by itself, start there. Now I have 8x minus 9 equals negative 41. Again, I want to use the opposite of the order of operations to simplify. So I want to start by seeing if I can add or subtract away from my variable. Again, I notice the side of my variable, in this case again, is the left side. The x is my variable, so the 8x is the term that has the variable in it. I want to add or subtract away from that term if I can. This 9 is currently being subtracted from my 8x, so the inverse of subtracting 9 would be to add 9, or you can say you're subtracting negative 9. Either way, those mean the same thing. I know if I'm going to add 9 to the left side, I also have to add 9 to the right side of my equation. On the left side, negative 9 and positive 9 add together to equal 0. So I'm left with just 8x. The identity property of addition says that if you're adding 0, you're not changing the value. On the right side of my equation, my negative 41 and my positive 9 combine to equal negative 32. Now I have a one-step equation. 8x, or 8 times x, equals negative 32. I can go ahead and divide both sides by 8. Or if I wanted to, I could say I was multiplying both sides by 1 over 8, the multiplicative inverse of 8. Either way, I'm going to get x equals negative 4. Again, it's always a good idea to check, especially as we're getting into these more complicated problems. When you do check, you want to go into your original problem whenever possible. So instead of going into this 8x minus 9, I'm going to go back into the original problem. Because if I made a mistake there, I want to be able to catch it. Three times negative 4 is negative 12, plus negative 20, minus 9 should equal negative 41. I'm going to go ahead and simplify. I get negative 32, and another negative 9 is negative 41. And that does equal negative 41. I'm left with something that is just true, so it does check. My answer is right here, x equals negative 4. Okay, I know some of you guys have wanted to see Madison, and she has been wanting to say hi to you too. So here's Madison. Just so we're clear, she said, "Hi, PMS."